Greeting from us. Thank you for the opportunity to present here in SBCC 2024. My name is Wira. With my team, we would like to share our research, and the title is Passive Cooling Design Opportunity, Listen Learn from the Traditional Banjar Houses. Passive cooling has gained significant to climate change and the energy saving. In terms of topic, previous study found that vernacular design is more responsive to their surrounding climates, emphasize the adaptation to the environment, climate, culture, and social context in the development. Ventilation can ensure the room temperature when upcorrect and result in entry of solar heat. Even though some vernacular buildings have undergone modification, vernacular buildings continue to survive today. Indonesia is the largest archipelago country with thousands of ethnic, rich in culture and vernacular. The culture within the tribes in Kalimantan is rich and encompassed from the mountainous to waterways religions. Banjar vernacular architecture with the focus on three houses type, Bubungan Tinggi, Palimbangan, and Lanting House. Their research aims to contribute to the development of passive cooling strategy based on the local culture heritage of the Banjar tribe with modern technology using CFD simulation of vernacular buildings. And the methods, the first is the literature research regarding the target Banjar house type, namely is Bubungan Tinggi houses, Palimbangan house, and Lanting house, regarding the width, depth proportion, and house characteristic. Second, run the simulation in Erwin Durbal CFD. Have a two parameter. One is the 2D burn speed data in Banjar, 3.5 meter per second and 70 meter per second. The second, their different prevailing wind direction is a diagonal, perpendicular, and parallel to depth of the house. The findings in each house are then being compared to understand more regarding the efficiency of passive cooling strategies in the implement local wisdom from Banjar. And the result is Bubungan Tinggi characteristic is partition to more private to area, has a high pitch gable roof with 70 degree angles and 6 meter height for the roof. And the Palimbangan partition to more private area. And the roof attic area could reach 3 meter in height. Large openings make the cross ventilation move efficiently when open and help the thermal performance of the buildings. And Lanting house, there is a 3 to 5 meter space between the houses, the park, the jukung board. Rarely partition and does not have a ceiling. The total height of the Lanting house is 4 meter. The roof is usually a low gable roof with angle variation between the center and the perimeter area of the roof. And the result is a Palimbangan house, Babungan Tinggi house, and Lanting house. Then the maximum wind speed is used for the simulation. It shows us a better performance on the passive ventilation. This could be a challenge in application of the passive cooling toward wind movement, as the density of the city has enveloped, making the wind speed far slower than the past. And the Kalang has created of wind streamline below the activity area. The gaps between the wooden floor panel and wooden beam configuration can serve a leak outlet for the houses. that remove the humidity in the house. Bubungan tinggi house has a higher space of kalang than the Palimbangan house. The speed found in the Bubungan tinggi kalangs is faster than the one in Palimbangan house. Partition in Bubungan tinggi house causes a curtain area with stagnant wind movement. The large back opening helps the wind to reach more air in the back area of the Palimbangan house. At Lanting house, the roof can direct wind move to fill the gaps between the houses. Can you see the picture? In the conclusion, the opening design in all of the types has different effect on the wind movement throughout the buildings. The first, in Bubungan Tinggi house, the additional window with different orientation ensure that the additional space that adds with the whole building can obtain direct fresh air from the surrounding. The partition in this house block the wind movement, so that the wind does not pass a curtain area of the house, mostly at the back side of the house. Palimbangan house has the most balanced passive cooling performance throughout with the movement, as the wind could reach in almost 90% area of the houses when exposed to different prevailing wind direction, even in a minimum wind speed. Future research that integrates temperature in the wind movement is necessary to study the possibility of stack effect in this curtain vernacular building. And the reference is this, and thank you for your attention.